Here we have AP calculus AB problem. There is a graph over here. In the graph of the function f of x shown above, identify the intervals where f prime of x is less than 0 and f double prime of x is also less than 0. Okay, so let's understand what is f prime of x and what is f double prime of x. Usually f prime of x represents the slope of the graph of the function f of x. Okay, so since the f prime of x, the first derivative is less than 0, the slope is negative. So then the graph of the function f of x must be falling when I look at the graph from left to right. That is, the graph must go down from left side to right side since the slope is negative. And also f double prime of x, the second derivative will always give the information about the concavity of the graph of f of x. If the second derivative of the function is greater than 0, that is positive, then the graph of the function f of x will be concave up. But if it is negative, that is the second derivative is negative, then the graph of the function f of x will be concave down. Since the second derivative f double prime of x is less than 0, then the graph of the function f of x must be concave down. So we have to find the intervals where we have the values of x. So for which both these two conditions are satisfied. That is, f prime of x has to be less than 0 and f double prime of x also must be less than 0. So that we have to find the intervals where we have the values of x. Okay, so now let me take the first condition, that is f prime of x is less than 0. That is, slope has to be negative. So I have to identify the part of the graph where it is falling from left side to right side. That is, the graph must go down. Okay, when I consider the interval negative 2 to 0, clearly the graph of the given function f of x is falling because it's going down. So clearly in this interval from negative 2 to 0, so the first derivative, that is f prime of x, is negative. So we can write the interval over here which satisfies this condition. And also from 0 to 1, so the graph of the given function is going down. So that is, it's falling. So we can write that interval also, that is 0, 1. So because in this interval, the slope is negative because the graph is falling. From 1 to 2, it's going up, it's raising. Okay, now let me consider the interval 3 to 4, because in this interval 3, 4, the graph is falling. So in this interval 3, 4 also, the first derivative, that is the slope, is negative. Let me write that interval also. So we have three intervals where the first derivative is negative, that is, the slope is negative, because in all these three intervals, the graph of the given function f of x is falling. Okay, now to find intervals for this condition, that is f double prime of x is less than 0. So I have to find the part of the graph where it is concave down. Okay, so here let's consider the interval negative 2 to 0. So the graph is concave up, so we can ignore this one. So from 0 to 2 also, the graph is concave up. Let's ignore this one also. From 2 to 4, clearly the graph is concave down. Since the graph is concave down between 2 and 4, so f double prime of x must be negative. So that is, f double prime of x less than 0 in the interval 2, 4. But we have to find the interval where f prime of x is less than 0 and also f double prime of x less than 0. So for that, we can compare the intervals we have for f prime of x less than 0 and the interval we have for f double prime of x less than 0. Now let me take the first interval of this one and it has to be compared with 2, 4. Are they coinciding? No, because negative 2, 0 is over here and 2, 4 is over here. So this interval and this interval do not coincide, so we can reject the first interval over here. Now let me compare this interval 0, 1 with this 2, 4. Are they coinciding? No, because 0, 1 is over here and 2, 4 is over here. So these two intervals are also not coinciding. We can reject this one as well. Now let me compare this 3, 4 and 2, 4. Are they coinciding? Yes, because 3, 4 is over here and 2, 4 is over here. So what's the common region for 2, 4 and 3, 4? So clearly it's 3, 4. In this interval, the graph of the given function is falling. So the slope has to be negative. That is, the first derivative f prime of x is less than 0. And also in this interval 3, 4, the graph of the given function is concave down. Then the second derivative, that is f double prime of x, is less than 0. So 3, 4 is the interval at where f prime of x is less than 0 and f double prime of x is also less than 0.